Okay, so like I was saying, then, the topic that we are going to be having a look at is decimals at this point. In regards to functional skills, there's not really many things we need to know about decimals. We do need to know about them in terms of conversion, but there's a couple of key skills that pop up quite frequently. One of them is being able to order these decimals. It's quite a common question. We might be given a couple of decimals in a row and just be asked which one of these is the biggest or which one is the fastest, maybe if it's linked in with time. Ordering decimals does really help us when we come to look at conversion at a later point as well, because by switching fractions and percentages to decimals, we can easily see which one is bigger, whereas with fractions on their own, it can be a little bit difficult. So a little bit about ordering decimals, a little bit about rounding decimals as well. This is really the key topic from this section. If you are able to round decimals, that's the main thing that we really want here. It tends to pop up on every single paper, level 1 and level 2. Normally just a 1-mark question. They'll just attach this as a bit of a kind of bayonet question at the end of another question. So it'll be a 4-mark question. Then at the end, it might say, round your answer to 2 decimal places. If we know this skill, we're going to very easily pick up some of those extra marks there. So that's why it's such an important skill there. Estimating, we've already covered in the previous video. And then we've got our assessment and our recap at the end there. So as a very, very quick one, essentially, when we are ordering decimals, we always do the same thing as when we're ordering normal numbers as well. A lot of people can get a little bit confused with this. The idea with our numbering system is that everything, we have 9 in, let's say, the units column. When we go to 10, it moves into the next column. So everything in a column to the left is always going to be larger than anything in a column to the right. And it's the exact same with decimals as well. So if I put up these 2 values here, then what some people will do is they'll immediately look at this and think, oh, well, the top number is bigger because it's got more kind of decimals to it. It's not the case. The biggest numbers are on the left. Again, if I had hundreds, it doesn't matter how many tens I've got, having 100 is always going to be more. How we actually say these numbers as well is very important. So the bottom number there, for instance, we wouldn't, if I were to read that number out loud, I wouldn't say 0.481. It wouldn't be that, it'd be 0.481. It's indicating a unit in each column. So if I wanted to compare these and see, well, which one of these is the bigger number, it's just a case of comparing across at each value. At the beginning, they're both 0. So we're going to move along there because, well, they both be equal in that point. If we look along to the first decimal place, so in regards to our the names that we associate to these things, this one here will be the first decimal place. It's the first number after the decimal. This will be the second decimal place, the third decimal place, and so on. We need to know really up to 3 decimal places. That's where we'd be asked to essentially round to. But we've got the first, second, third decimal places there. Obviously, these can go on for infinity. You could have the 980th decimal place. But this is the terminology that we use in functional skills. Obviously, they do have other names as well. So this could be essentially the tenths, the hundredths, and the thousandths column. But you won't see that word in functional skills. It's the same thing. Again, it's another synonym that we have in English. But in this case, we wouldn't use them. It'd be the first, second, and third decimal place. But if we have a look here now, then we can see, well, at this point, if we just look at the first decimal place, I've got 0.4 and I've got 0.4. So these are, to all extents, at this point now, the exact same. So I'm going to track along. I'm going to have a look at the next decimal place, and this is where the values change. So at this point, I can then say, well, I've got a 5 in the top and I've got an 8 in the bottom. That means that the lower decimal, at this point, we can determine that this one is the larger decimal. So these kind of top decimals here, it doesn't matter how many numbers follow, they're all smaller numbers. Again, if you imagine this, put it in context of money always helps. Which is more, 45p or 48p? It's the same idea, you know, if we would change one of the values here, and let's say this is 51p, this one would then be the largest because it's got a 5 in a higher category further to the left. So in regards to this group in particular, I am aware that ordering decimals was not a problem. So we're not going to look at many more kind of practice questions for this. The main thing to remember is that if you are ordering decimals, it's always the biggest number on the left, just as it is with whole numbers. Nothing changes in that context. It's also the same when we talk about rounding, and we'll see that in just a second. Okay, so with rounding decimals then, like I mentioned, we might need to round up to 3 decimal places. It doesn't mean it's any harder. Rounding to 3 decimal places is the exact same as rounding to 2 or 1 or 5 or 100. That's just the level of accuracy that we need. And if you think about it, if I was maybe weighing out, how many grams of sugar I'm going to put into a cake or something like this, I'm going to probably just have the nearest gram, either 10 grams or 11 grams. If I wanted to be really, really precise, I could say maybe, it's 10.5 grams. I'm not really going to go any further than that. I mean, it might be that for the ultimate best cake in the world, it'd be 10.463 grams. It just depends what level of accuracy you want to measure to. So we round numbers to make them simpler, as I kind of mentioned. It's a desired level of accuracy. When we look at pi at a later point, we always seem to use pi as 3.14. The number itself potentially goes on, it does go on forever. So we could use it as 3.1415, for instance. We don't really tend to use it if you were working in a certain industry and you needed these circles that you're making to be really, really precise for certain mechanics or whatever it might be, then you'd use more digits of pi. So that's the idea with this rounding. There is another idea linked in with rounding, which is only really for functional skills problems, but I want you to be aware of that. And that's something called logical rounding, which we'll look at in just a moment as well. But first of all, we need to get this idea of how to actually round to certain decimal places. So the key concept with rounding is all about our high five rule. And if we use some whole numbers just to start here, again, I'm not going to ask anyone to put in the answers yet because it's a bit of an explanation. But let's say if I had the number 12, if I wanted to round that to the nearest 10, it's going to be 10, not 20. So from 12, if I'm rounding to the nearest 10, all I'm saying is, well, which is it closer to here? Is it closer to 10 or is it closer to 20? Because the 2 kind of puts it in between those 2 values. Now, because the 2 is lower than halfway, it's going to round down. If I've got 12 pounds, I'm closer to having 10 pounds than I am to having 20. That can vary a little bit, though. If we change this number here and let's say we make it 16 pounds, then obviously 16 is closer to 20. It's only 4 away from 20. It's 6 away from 0. So this one would round up to the nearest 10. The only other thing that we need to kind of bear in mind with this is, well, what happens if it's smack bang in the middle? In terms of maths, we are always optimistic. So it is the high five rule of maths. If it's a 5, we always round upwards. So if I had 15 pounds, I'm not going to tell people I've got 10 pounds. I'm going to brag a bit and be like, nah, I've got 20 pounds. Nice. So the only other thing that I'll mention at this point is the length of these kind of values as well. So if I extend these a little bit here, and then I'll extend this top one as well. So let's say with this value here, I've got 1,512. Now, if I want to round this, let's say to the nearest 100, I'm sure most people are quite happy at, well, this is the hundreds column. The options are therefore, well, it's either going to be 1,500 or 1,600. What is it closest to? It is the tens that determine that. Tens there determine, and they say, okay, well, it's, we've only got a 10 after it. It's not a 5 or higher. It's going to round downwards. That's the important thing here. And it's good to notice that, whatever this end digit is, doesn't change the value. This could be a 9 in here. It doesn't matter how big this value here is. When we're rounding to the nearest 100, in this case here, we only look at the one column next to it. With whole numbers, that makes a lot of sense, because, well, if I'm round to the nearest 100, how many tens have I got? That's going to determine it. If it was the nearest 1,000, then it'd be, well, how many hundreds have I got? I'm going to look at the hundreds, not the tens or the units, because they're not as big and they're not as relevant. It's the same thing with all decimals. All decimals, we will round from the one number to the right. The reason that we do this is if I imagine, let's say, this number here. Now, the reason that we only round from one number to the right is some decimals like this, they go on for a long time. Some of them, like pi, go on forever. So trying to find the end of the number will take you an infinite amount of time, and you've probably got better things to do. So we are also, just remember, the reason we're rounding is to save time. So if I want to round this to one decimal place, so it's going to be, my options here would be 0.4 or 0.5. Those would be my two options. All I'm going to do is look at the next value. It's a 4, it's not 5 or higher, so I can just chop all of that and get rid of it. What I don't do is go to the end of the number and go, well, that 9 will round the 4 to a 5, then that 5 will round this up, and that will round this up, and so on and so on. As I said, it takes more time. It could essentially go on forever. So we only look at the one digit next to the one that we're working with. And just remember, when we're rounding with decimals, it is the exact same as rounding with whole numbers. We're just looking at that one next number. So, for instance here, if I've got 6.752, and I'm going to round this to one decimal place, my first job is working out where is the first decimal place. So I draw a line here. I've now got my two options. Essentially, I've got, this is either going to be 6.7 or it will be 6.8. It's got to be in between them. It will never go down to 6.6 because it's already above 6.7. So it's going to be closer to 7 or to 8. It will never be any lower than that. The thing that determines it, as that kind of circle there shows us, is the one number next door to it. In this case, that's a 5. It's 5 or higher, it's going to round up. I've got 6.8. The same concept then, let's take the same number, but this time I want to be a little bit more accurate, and I'm going to round to 2 decimal places. The only difference here is how accurate I'm being. The math isn't any harder, nothing really changes. Okay, second decimal place is where that 5 is. So I'm going to put my line in there. All the other numbers I will get rid of. My options are 6.75 or 6.76. It's only that very end number that's going to change. In this case, you can imagine the top one is rounding to the nearest 10p, and the bottom one is rounding to the nearest penny. So in this case here, I'm going to look at the next number there. It's a 2, so that's not going to impact it. It's going to remain the same. And this number is therefore closer to being 6.75 than it is to being 6.76. Okay, so the main steps then just identify the right decimal place. We're going to then look at the one number next door to it. How will this impact it? Is it going to make it stay the same, or is it going to increase by 1? Those are the only two options that we're going to get. And finally, it's only ever going to be changed by 1 or not at all, just as a little extra point there. So it might be in this case, you know, if this was 6.9, for instance, then this would round up the 9. It's like just our counting system. The 9 becomes a 10. That's it. It's never going to increase by more than that. Okay, like I mentioned previously, in functional skills, it tends to be that this skill or this rounding skill is like kind of put on the end of a question. So that will be something to consider when you're looking at the marks. If it's a 5-mark question and it says, give your answer to 2 decimal places, is John correct? That's already going to be 2 marks at the end there for stating, yes, John is correct, and for having your answer rounded. Do show all of your workings, do your normal calculations, and then at the very end, then round your answer off. Just in case if you happen to round the answer off and it's not quite the right value, then that could potentially cost you a mark there. Okay, here are some practice questions for you then. What I want you to do is have a look at these numbers and see if you can round them to 1 decimal place, and then see if you can round it to 2 decimal places as well. So we're just going to have a little bit of time looking at this. If you want to just kind of do these on paper and then let me know when you've done a few and we can check them, that's fine. If you want to send the answers over, that's also absolutely fine as well. We'll have a little bit of a look and see how this understanding is. From everyone's initial assessments, it seems like the majority of people are quite happy with this kind of rounding decimals idea, which is why I thought we'd cover this topic first today. Okay, so yeah, Anita, those first were absolutely spot on. 3's fine as well. 4's fine, and yeah, absolutely spot on. Technically speaking, for number 5 there, you wouldn't have to put the 0.0. You could just leave it as the 63, but you're not going to get marked down for that as well. I'll explain a little bit more about that in just a moment. So yeah, maybe have a bit of a look, see if you're quite happy with rounding to 2 decimal places as well. But it seems like you've got the hang of it. Okay, great stuff. Absolutely fine there, Anita. You've got no problems at all. Again, do please remember, you're not going to see this type of question in your exam as well. This is just us looking at the like the main kind of like the technique, so to say, or the understanding, just making sure we know how to round things and why. The context that we tend to get given these is, again, at the end of a question. It tends to be, give your answer to this level of clarity. I've got a few answers coming in there then. And I was about to say, Claire, yeah, I've literally just noticed that as well. So yeah, as always, if you can, when you send the answers over, if you can send them over directly to myself, always makes it a bit easier. So Anita, please don't worry, but obviously those answers have gone to everyone, so the cat's out of the bag. But at least everyone knows that you got them all kind of correct.
Sorry, I didn't know.
Don't worry, you're absolutely fine. Like I said, it happens every single session. It's a very easy thing to forget, so please don't worry. I'm just happy that you've got them correct. That's the main thing. So, but I just saw Cleo's message pop in as well, and was like, oh, no. Okay, I'm just going to go through one or two of these and explain them quickly, and then we can kind of move on from there. So, with these ends, so our first kind of answer here, nothing really changed here. This is a bit more of a straightforward one. So 10.615, if I'm going to round that off, well, if I'm rounding to 1 decimal place, I'm going to draw my line. It's going to go between my 6 and my 1. The 6 is in the first decimal place. So my options are 10.6 or 10.7. So in this case, it's going to remain at 10.6 because that is closer to the 6 than it is to going up to the 7. 2 decimal places, very, very similar here. So it's just looking at the next place there, 10.61 or 10.62. Which way is it going to go? Well, the 1, if I look at the next value to it, it is a 5. That will then round upwards, and we're going to end up with 10.62 there. Now, the next one varies a little bit, which is why I thought I'd leave it in there. So first of all, 3.7 is the optimum answer here. So 3.698. That 9 is going to round the 6 upwards to a 7. Now, when we look at this to 2 decimal places, we actually get the exact same answer. When we look at the 9 here, it's going to be the 8 that determines whether or not this goes up or stays the same. It is going to go up. The only way to go from a 9 is to a 10. So the 1 will carry over here. Just simple counting, this will become a 0. Now, the great thing here is either way you write this, you'll get the mark. If you write 3.70 or 3.7, they will award you a mark. It's one of the advantages because in GCSEs, if you wrote this, you would not get the mark. The reason being, technically, that 0 doesn't tell us anything. If we think about a number, there are zeros everywhere. I could say, well, 3.7, there's nothing in the kind of hundreds, in the thousands, in the tens of thousands, in the hundreds of thousands. There's also technically nothing in the tens, in the hundreds, in the thousands, in the 10,000s, and 100,000s, and so on. So technically, because we don't need that 0 there, you wouldn't really write it on, but you're not going to lose the mark for it. The one that I need you guys to be more careful with is if we talk about money. So I'm going to put these answers up here. So anyone that's been working along, you can have a quick scan while I'm kind of explaining this concept. But yeah, in regards to money, we're always looking at 2 decimal places. Our monetary system is based on a scale of 100. We have 100 pence in a pound. So those are the 2 units, just as there are 60 minutes in an hour. So if we were dealing with money, for instance, let's say I had this number here, 10.615 pence, then I would round that automatically to 2 decimal places. At the end of my calculations, I'd say, well, that's going to be £10.62. So just so you're aware, if we're dealing with money, it's always going to be rounded to 2 decimal places because of our 10p's and our individual pennies. With the only other thing I'd say with rounding in general is if you do have very, very large numbers, it makes sense just to round them at the end. So once we've kind of done a calculation, keep as many numbers as you can on your calculator. If you have one of these scientific ones, they will remember as many values as they can. But even so, I'd say always maintain at least kind of a minimum of 3 decimal places. If you're finding very large numbers, try and keep using them for as long as you can. But normally it means that they will accept a range of answers at the end. And we'll see more about this as we move on. So it's just one more concept that we need to talk about in regards to kind of like rounding decimals, and that's the idea of logical rounding. So it just basically works on the idea that a lot of the problems that we're looking at are functional. So they're based on real life kind of situations. So like I mentioned earlier, during your working out, just round it right at the end. It's going to make your answer at the end even more accurate, but they will accept a bit of a range of answers there. Now, this logical rounding idea is the only kind of place when we don't use that conventional high 5 rule. If it just says round to 2 decimal places, then that's what we're going to do. No problem. And we're always going to use this system. However, let's say I've got this problem here. So we go through, we're trying to work out how many tins of paint someone needs to, let's say, paint their house. The answer, let's say, comes up that they need exactly, let's say, 5.4 tins of paint. So the problem here is, it's very difficult to go into a shop and go, oh, excuse me, can I have 0.4 of a tin of paint? They don't tend to sell them. They might sell smaller kind of pots of paint, but in this case, in this situation, it's saying a tin of paint is this. If you need 5.4 of them, then you have to buy 5. And that would be the exact same, even if it was 5.1, 5.12 tins of paint. I'm going to round it up because if I'm painting my house, I'm going to paint it, and then I've got 0.12 of a tin of paint, which I haven't got, which means I've got a little blank spot on my wall and people are going to think it's a bit weird. So this is a really common kind of context. Most of the time, if you work out the answer exactly, you're going to get the marks. There are, however, some times where they will ask you to be maybe working out a price. Price here is obviously going to be the price of 6 tins of paint, not 5.12 tins of paint. So do just try and bear that in mind, that it's these kind of real life contexts that these are put in. It can kind of act in reverse as well, if in regards to like how many people can fit safely in an area. Let's say if it's, each person needs a certain amount of space. If we end up that we can fit 5.9 people, it doesn't matter if it's 0.9 of a person, that's not a whole person. So there is not enough room. If by involving that extra person, everyone would have a little bit less space and it would break the rules. So that's the idea of it. So we're not going to move on to estimating because we've already covered that in the first section. So for us, in regards to our decimals content, this is all we need to know. So we need to know how to round numbers, which decimals are larger, which ones are smaller, and then just this idea here of kind of logical rounding as well. So I'm going to go and stop the recording at that point then and say to anyone rewatching this recording in the future, have a go at the assessment now for level 1 or level 2.